Hello, students. So, let's talk about polynomial division. And this short set of notes is going to take us through a single example of polynomial division, and will motivate a few of the different ways to think about it. And I think here's the example that I'm going to start by thinking about. And the reason I'm picking this example is that it is exactly that supplemental in the notes. So, let's do some polynomial division, and we'll do it 4 different ways. We'll think about computing coefficients, starting with the highest degree and just walking our way down. We'll play the game that we played in class where we try to factor by grouping and just seeing what happens. That'll motivate the algorithm that is polynomial long division. And finally, there's a very abbreviated version you can make in a special case called synthetic division. We'll do that. So, let's start by seeing if this even divides in evenly. And here's how I'll do it. If this is actually a polynomial, its graph should look like a polynomial. Its graph should look like a degree 2 polynomial. So, let's do that. There's the polynomial q of x. There's its graph. I would like to know if that polynomial, oh no, I shouldn't call that q of x. That's not what it's called. There's the polynomial I'm interested in. In fact, let's not give it a name yet. I want to think about that thing divided by x squared plus 1. Oh, hey, look, that still looks like a degree 2 polynomial. So I expect this to still be a degree 2 polynomial. Maybe in order to see an example where that doesn't happen, let's see what happens with that instead of x squared minus x plus 1. If you check that out, there we go. We see something weird going on. We see that there's this vertical asymptote here. Well, honest to God, polynomials don't have that. So this isn't a polynomial anymore. But let's focus on this example. So here's the strategy that I'll endorse. Let's see. I'm going to write down the quotient I want to compute. I want to compute q of x equals x to the 4th plus 2x cubed plus 4x squared plus 2x plus 3 all over x squared plus 1. All right, so let's think about what this even means. Computing this quotient means that you want to solve x to the 4th plus 2x squared plus, nope, that's 2x cubed, plus 4x squared plus 2x plus 3 equals q of x times x squared plus 1. And if you this is the same for normal numbers. If someone asks you to compute 73 divided by 27, if that's some quotient, I'll call it star to make sure it's not a variable name I've used. This means you need to solve 73 equals 27 times star. You want to find the value for star that makes that happen. Same thing here. I want to find a q of x that makes this happen. And if you recall by looking at that graph, it should be degree 2. And another way to see this is this piece is going to be degree 4. This thing is degree 2. 2 plus what is 4? That's right, 2. So this thing has to be degree 4 minus 2, also known as 2. All right, let's think about what that means about that q of x. So this q of x has to be a square term plus some lower order terms. I'll just call those L of x. I guess happily it's L of x, both L for lower order terms, and that's degree 2. So this is a linear term and a constant term. So this is the linear part of this quadratic. All right, well, let's plug this in for that and see if we can solve for a. Let's do that. So that would mean x to the fourth plus 2x cubed plus 4x squared plus 2x plus 3 is equal to ax squared plus L of x. Because that is q of x. And then the other piece, I'll just bring it along for the ride, x squared plus 1. And now what can I do? I can FOIL out the right-hand side. Ax squared times x squared is ax to the fourth plus ax squared plus, well, I said FOIL, but I guess this isn't really the FOILing algorithm, plus the terms that have an L of x next to them. So that should be equal to the right-hand side. And the only way for these two polynomials to be equal is if their coefficients all agree. So ax to the fourth has to line up with x to the fourth. I can't just say a has to equal 4 because there's going to be a square term coming from this. All right, so let's use that. A equals 4. And if I plug in a equals 4, then let's see, I can subtract ax to the fourth from both sides, because a is 1. A is 1. And let's see what that'll give us. That'll give me 2x cubed plus 4x squared plus 2x plus 3 equals, a is 1, so that's x squared plus L of x squared plus 1. Oh, neato. Now I can cancel an x squared to the other side. Minus x squared, giving me 2x cubed plus 3x squared plus 2x plus 3 equals L of x squared plus 1. All right, so let's look at both sides again. This side's degree 3. This side is degree 2. L of x, that's degree 3 minus 2, also known as 1. So this piece is a linear function. Alrighty. So that means I can replace L of x with bx plus c. Maybe you'd like mx plus b. Oh, sorry, I was off the page for a bit there. Maybe you'd prefer mx plus b, but it doesn't matter what coefficients you use. Can't use a. A already has a job. In fact, this a equals 1 is important. I want to say that. Alrighty. So let's plug in bx plus c for this L and see what we get. 2x cubed plus 3x squared plus 2x plus 3. Don't need those parentheses. Those actually be harmful parentheses. Equals L of x is bx plus c times x squared plus 1. And now let's play the same game. Let's FOIL out this side. Now then we'll match up some coefficients. Equals first bx cubed plus outside inside plus last. Alright, so now we can match up coefficients again. That's the only cube I see on the right-hand side. That's the only cube I see on the left-hand side. B has to be 2. And let's see. The next B is determined. It has to be 2. Oh, good. That agrees with the 2x that I see on the other side. That's good. Cx squared, 3x squared. C has to be 3. And the constant term there is now 3. Yeah, that lines up with that. So let's see what that means. So let's recall what we started with. We started with, there's the thing that we made. believe I just copied it down correctly. And what have we accomplished? Sorry if it was going out of focus. Oh, divided by x squared plus 1. So let's see what we got so far. So we got so far q of x equals, well, I don't need to say this, ax squared, where a is 1, plus some lower order terms, equals 1x squared plus the lower order terms. Well, the lower order terms were bx plus c, now b equals 2 and c equals 3. Don't need to put the 1. It's x squared plus 2x plus 3. And now let's do a quick check. But I think I want to check this two ways. Here's the first way. We have this Desmos graph going. There's the thing that I was hoping to get. And I just got x squared plus 2x plus 3. Yeah, that looks pretty good. Here's another way to check that will, again, be remembering what polynomial division means. Let's do it by computing x squared plus 2x plus 3 multiplied by x squared plus 1. You do that, let's see what we get. X squared times x squared is x to the 4th plus 2x times x squared is 2x cubed plus 3x squared plus x squared plus 2x plus 3. Right, so it doesn't matter what order you wind up writing those terms in, as long as each term in that factor is multiplied by each term in that factor. So you should wind up with 3 times 2, so 6 terms. I see 6 terms. Now it's combined like terms. X to the 4th is x to the 4th. That's the only cubic term I see. I see 2 square terms. Oh, nice. Oh, hey, that's the exact same as the numerator. That checks that off. Cool. So we've computed this bit of long division. It is that. Neato. So hopefully that felt pretty good. Let's talk about a way to do that that will work out to be a little bit faster, significantly faster in fact, and use less space. So again, let's compute the same thing. Let's compute x to the 4th plus 2x cubed plus 4x squared plus 2x plus 3 divided by x squared plus 1. So here's another way to think about polynomial division. I'm going to do it by following the long division algorithm. So I want to see x to the 4th plus 2x cubed plus 4x squared plus 2x plus 3. I want to see what happens when I divide into that x squared plus 1. And it turns out the algorithm I'm about to follow, it'll break down a little bit if you're missing any terms. So if there were any missing terms in that sum, then I'd want to put a plus 0 times x cubed if there weren't an x cubed term. There wasn't an x term in this side, so I want to put a plus 0x there. Now that I have that written down, here's the algorithm I'll follow to do polynomial division. And I'll try to motivate it a little bit. So this b, why was that b a b? Well, it was because I needed this bx cubed to be 2x cubed. Well, so that where did this bx cubed come from? It came from bx times x squared. So this bx was, what do I need to multiply x squared by to get this 2x cubed? Where did this a equals 1 come from? It came from this ax to the 4th. That came from ax squared times x squared. What do I need to multiply by x squared to get this x to the 4th? So at each stage in this process, I'll ask myself, what should I multiply this by to get that? X squared times what is x to the 4th? Well, that's x squared. So you should think of this as being like, what's the 0th guess for what this result of division should be? It should be something like x squared. And now, well, the answer is obviously not that, so let's see how far off we are. So I'm going to do x squared times that, and I'm going to subtract the result. Minus x to the 4th minus 0x cubed minus 1x squared. You do that bit of division, and what do you get? I'm going to switch colors now. 2x cubed minus 0x cubed is 2x cubed. 4 minus 1 is 3, so minus 3x squared. So now I look at the next term, this 2x cubed term, and ask myself the same question. What do I need to multiply x squared by to get 2x cubed? Well, 2x. And now I play the same game. 2x times x squared is 2x cubed, but I need to subtract the result. 2x times 0x is 0x squared. 2x times 1 is x. Sorry, is 2x. Now do the subtraction. I'm going to switch colors again so that we can see at the end what pieces corresponded to which. 2x cubed minus 2x cubed is 0x cubed. Well, we knew we had to get a 0 there. That's why I didn't bother to write it there. Minus 3 minus 0 is minus 3x squared. 2x minus 2x is 0x. All right, so I look at the biggest term, negative 3x squared. All right, so it's really easy to make mistakes when you do this, and without an audience to catch these mistakes for me, I'll make more. 4 minus 1 is plus 3x squared. That's a plus 3x squared. X squared times what is 3x squared? Well, 3. 3 times x squared is 3x squared. Let's write that down and subtract the result. Minus 3x squared minus 0x. 3 times 0x is 0. 3 times 1 is 3. Subtract that result. Cool. So the remainder term is 0, which is what we said it should be. Nice. So there's the polynomial long division way of doing this. Neato. So, with that being done, what I think I'll actually do now is pause the video, stop the recording in fact. This will be one of the recordings I'll post, and then there will be another one in which I motivate synthetic division. Cool. Thanks for watching.